guys, today we are going to be talking about justifying algebraic properties. Okay, so we're going to be given an equation, and up to now we've just been actually working our way through the equation and solving, but we're going to think about each step today, and we're going to apply the property that we use to actually get to that step. So if you have the property sheet, that would be really good to reference while we're going through this. If not, just try to follow along on the first example. So the first example we have, we're just going to look at it. We have this equation right here. All right. And when we're doing this justification, we always start out with our first step being the exact same as what's given. And the reason is given. So you're going to say given on that first step. Okay, so we write that down. And now looking at the second step, if you look at how do we go from the first step to the second step here? Okay, if you look at it, we distribute it. So that's why it would be the distributive. That's the reason. Okay, from here, we're combining 7x and 2x, and we get 9x. So that's actually substitution. So 9x is substituted in for 7x plus 2x. And the next step, we look at it, we are actually subtracting 12 from both sides of the equation. When we do that, the property that we're using, the golden rule of algebra, is actually called the subtraction property of equality. And now this is important. This is equality because if you notice right here, this is an equal sign. If it was a less than sign or a greater than sign or less than equal to or greater than equal to, then it would be an inequality. Okay, there's a little bit of a difference, and some of the examples we'll do will have the inequalities as well. Okay, so now when you take 12 minus 12, you actually get 0. Well, that's like saying 12 plus a negative 12, which is 0, which is the additive inverse property. Okay, and then 39 minus 12 is 27, so we're substituting in 27. So we have two things going on there. Okay, so to go from 9x plus 0 to just 9x is actually the additive identity property. Okay, remember if you add 0, you just get, so if I had 9x plus 0, that's the same as just 9x. Okay, that's the additive identity. Okay, so now at this step, we're actually dividing both sides by 9, so that would be the division property of equality. 9 divided by 9 is actually the same as 9 times 1/9. Okay, that equals 1. So that's actually the, well, substitution on this side, but there's another one missing. It's actually the multiplicative inverse. Okay, so the multiplicative inverse is also happening here. All right, and then 1 times x is just the multiplication identity property because 1 times anything is just the number itself. Okay, so looking at the next example, well, we look at the first line and notice they're both the same, so this is given. Okay, first line should always be given. All right, when we look at what they did here, they actually rearranged the grouping. So this would be the associative property of addition. And I'm going to abbreviate a little bit of add. Okay, now from here, 3 plus 7 equals 10. Okay, so they substituted in there, but there's two things going on here. First, we're actually substituting. We took what was in the parentheses. We substituted in 10. But then we're also, it looks like we are subtracting 2x from both sides of the equation. So this is the subtraction property of equality. Okay, equality. All right. And then 2x minus 2x is 0. That's additive inverse. Okay. But 4x minus 2x is 2x, so that's going to be substitution. All right, if we take 0 and we add 10, we get 10. That's because of the additive identity. All right, now looking at the next line, here we're subtracting 2 from both sides of the equation. So it's the subtraction property of equality. Subtract prop of equality. All right. And when we take 10 minus 2, we get 8. That's because of substitution. Substitute in. All right. But 2 minus 2, or 2 plus a negative 2 is 0, is actually additive inverse. Okay. 2x plus 0 is 2x. That's because the additive identity. And then here we're dividing both sides by 2, so it would be the division property of equality. Okay. The next step, 8 divided by 2 is 4. That's because of substitution. Get our answer. And 2 divided by 2 is 1, which is the same as 2 times 1/2. So this is the multiplicative inverse. Okay, 1x is the same as x because of the multiplication identity. And here we're just switching the order. If 4 is equal to x, then x would be equal to 4, so that's a symmetric property. Okay, so you can see we're doing all the steps, but we're giving the reasons for each one. And sometimes we will skip some steps, but want to be able to identify what property we're actually using. So the first one and this one, notice we have a greater than equal to, so this is going to be an inequality. All right, so be careful with that. The first one, we're just rewriting the problem, so this is just a given. And this is kind of getting you ready for formal proof writing when you go into geometry and your higher maths. Here, if we look at it, we just distributed. Okay, and this line we're subtracting, actually we're adding 15 to both sides of the equation, so let's get rid of that. We're actually adding 15, so this would be the addition property, and be careful, this would be the addition property of inequality because we're adding to both sides of the inequality. It's not an equation. All right. Negative 15 plus 15 they're going to cancel out or go to 0. So that's the additive inverse. Okay. So there's a lot going on here. Additive inverse. It really would have been 0 minus 5n, but then so we'll just say additive inverse and substitution. Okay. Now we're dividing both sides by negative. Notice we switched the sign, so that's a division property of inequality. All right, we end up with 1 because negative 5 times negative 1/5 would be 1. That's a multiplicative inverse property. All right, and substitution because negative 25 divided by 5 is 5. All right, and then this last step, 1 times n is just n. That's because the multiplicative identity. So we got n by itself. Okay, so that was an example with the inequality. All right, so looking at the next one here, I'm actually going to stop the video for now and actually have you guys try it on your own, and then compare it to the answer key that's out there on Student View, okay, or on the class website. So let me just get you to the second line here. If you notice, what are we doing here? We're multiplying both sides by 4. So this would be the multiplication property of equality. All right, and these 4's would cancel out. So that's how we get the 6x plus 4. And then from there, you can show me that you understand that you're distributing, and okay, try to identify all the other properties. So again, look at the answer key and check your work.